back with number 8 on the practice exam. Number 8 deals with the discrete time Fourier series. So A is asking us to find the Fourier coefficients of periodic signal with the fundamental period equal to n equals 6, and x of n, the signal is sine 2 pi 6n plus pi over 4. Okay, so we know that sine n equals e jn minus e minus jn divided by 2j. That's the same identity we used for the number 7 continuous time example, adjusting for the discrete time variable, of course. Okay, so let's jump in. So we can write x of n as equal to e j 2 pi with 6n plus pi over 4 minus e minus j 2 pi over 6 n plus pi over 4 divided by 2j. Okay, we can simplify this. This is just using the properties of exponents. And that's because e a plus b equals e a e b. That's what property we're using here. Okay, so let's write this a different way. Okay, in number 7, I talked about how a Fourier series is just a summation of exponentials, and that it is unique representation. So we know that x of n, the Fourier series representation, is ak e j k omega naught n, and k is our iteration variable. So we know from the problem statement that the fundamental period was 6, and we know the angular frequency is 2 pi divided by n naught, and that's 2 pi over 6. So our exponentials that are functions of n have 2 pi over 6 in them. That's our omega naught. And we see that here as well. So all that's left to do now is to assign the Fourier coefficients to their respective exponentials. So this is e to the minus j 2 pi over 6n. So that must be the k equals minus 1 term, because that's the only value of k here that would give us this. See, if we put k equals minus 1 here, we'll get this. So this is the Fourier coefficient here. So a to the minus 1 equals e minus j pi over 4 2j. And likewise, the value of k that's going to give us this is just 1. So that's the Fourier coefficient that corresponds to a1. So that's equal to e j pi over 4 divided by 2j. And like we said, if we get x of n as a summation of exponentials, it must be the Fourier series representation, because the Fourier series is just a unique representation of the signal that is a summation of exponentials. So this must be it. Okay. So B is asking us to find y of n if it's a periodic signal with n equals 6, and the Fourier coefficients are given as a0 equals 1, a1 equals a minus 1 equals 2. So that means all of the Fourier coefficients are 0, of course. And it's the same for part A as well. That's why we don't see, say, a3 and a4 here. It's because those terms are 0. Okay, so we know that the Fourier series for y of n is equal to and fundamental period is 6, so the angular frequency is 2 pi divided by 6. Okay, so now we can just go ahead and write this directly. We have the Fourier coefficients. The Fourier coefficients besides a0, a minus 1, and a1 are all 0, so y of n must be equal to, we'll start with the a minus 1 term, 2 times e j. At this point, k is equal to minus 1. Omega naught is 2 pi divided by 6 times n. Now we'll go to the 0 term, a0. That's just 1 because e to the 0 is 1. So now we're at the a1 term. So we get 2 times e at the a1 term, k is equal to 1. So j1 omega naught, which is 2 pi over 6 times n. Okay. And we can simplify this. And that, of course, it's just going to be 1 plus, now let's factor out a 2 here, e j 2 pi 6n plus e minus j 2 pi 6n. Okay, we know cosine theta equals e j theta plus e minus j theta divided by 2. So we almost have that. So if we multiply by 2 over 2 here, that's just 1, so that's fine, that's valid. We can bring this 2 into the denominator here. We would get equal 1 plus 2 times 2 is 4 times e j 2 pi over 6n plus e minus j 2 pi over 6 n divided by 2, so that's just cosine. 1 plus 4 cosine 2 pi over 6n. Okay, that's the final answer. We went from knowing the Fourier coefficients and the fundamental period, which enabled us to find the fundamental frequency, and that allowed us to find what y of n was. Okay, so C is asking us to find the Fourier coefficients for z of n, which we're told is equal to the summation of deltas, and we're told that the fundamental period is 2. Okay, so we know that omega naught is going to be 2 pi divided by n naught. That's just equal to pi. Okay, so now let's write the Fourier coefficients. The way we find that is just going to be